Now we will talk about the solution of Cramer's system. Suppose you have a Cramer system, ax is equal to b. We need the solution of this. Actually, this is the system of equations and we have converted it into matrix form. So first of all, we will check whether the system is Cramer system or not. First of all, we will check whether it is Cramer system. What does that mean? We will check that the coefficient matrix, the determinant of the coefficient matrix is non-zero or not. So if it is non-zero, then it is Cramer system. Okay? If this is non-zero, then it is Cramer system. Because if it is 0, then we cannot find the inverse of A, and if we cannot find the inverse of A, then this system has no solution. The solution of this system does not exist. Okay, so first of all we will check that the inverse of A exists. This means A inverse exists. So if A inverse exists, so the next step is to compute A inverse. And I told you how to compute A inverse. You will form an augmented matrix and convert it into row to echelon form, and the thing on the right side will be the inverse of this. You understand this? And then what is the solution of the Cramer system? The solution of the Cramer system is A inverse times B. This is the multiplication. So first of all, you will check whether the determinant is 0 or not. If it is 0, then you will go to the next step. Sorry, if it is non-zero, then you will go to the next step. If it is 0, then it is not Cramer system. You cannot proceed this method. So if it is non-zero, then you will go to this step. You will find the inverse of A. If you have found the inverse of A, then you will multiply the inverse of A with B in this way. Then you will find X. This is the method to solve the Cramer system. Look at an example. I will do the same example as which we have done previously. Let us do the same example here. So we will check whether this system is Cramer system. Since we have already checked that this system is Cramer system, so the first step is done. So the first step was to find the determinant. Since we have already found the determinant, it is non-zero, so the first step is done. That means since it is non-zero, so it guarantees that A inverse exists. Now I have to find A inverse. Let's look how to find A inverse. Okay, here is to find A inverse. We assume the augmented matrix, which is minus 5 2 3 minus 1 1 0 0 1. So first of all I have to make this 1. This can be 1 if we divide the row 1 by minus 5, or if you add 2 times 3. If I add here 2 times this number, still I can get 1. What does that mean? This corresponds to R1 plus this is the coefficient, and this corresponds to R2. So if I perform this operation in R1, then I can get 1 in the pivot entry. So let's look. R1 plus 2 times R2, I mean 5 plus 2 times 3, 2 plus 2 times minus 1, 1 plus 2 times 0, 0 plus 2 times 1, and this is the same, minus 1 0 1. Now just simplify these things. 1 0 3 minus 1 1 2 0 1. Now I have to make here 0. How can I make this one? 3 minus 3 times 1. What does that mean? This means R2 minus 3 times R1. So R2 minus 3 times R1, and this change will be done in R2. So let me write first R2. R2 minus 3 times R1. 3 minus 3 times 1 minus 1 minus 3 times 0. 0 minus 3 times 1. 1 minus 3 times 2. This is R2, and R1 is as it is. So 1 0 1 2, 0 minus 1 minus 3 and minus 5. Okay, now I will make here 1. How can I make this one? If I divide this row by minus 1. 1 0 0. Okay, 1 2. I am going to divide this by minus 1. Minus 1 minus 1 minus 1. I mean R2 divided by minus 1 is new R2. All of the minus will be cancelled. I will get 1 3 5. Okay, so the inverse of A is 1 2 3 5. Okay, so now what is the solution? The solution is, I have found the inverse of A. Now the solution is x is equal to A inverse times B. Solution is x is equal to A inverse B, 1 2 3 5. And what is B? Here in this system the matrix B is 3A 2B. If I multiply 1 times 3A plus 2 times 2B, 3 times 3A plus 5 times 2B. If we simplify this thing, 3A plus 4B, 9A plus 10B. This is the solution. Let's do another example. We have the system x minus 3y plus z is 4a minus x plus 4y is equal to a, 2x minus y plus 5z is minus 3. Solve. We have to solve with parameters a and b. We have to solve this system with parameters a and b. So here is no b, only with parameter a. So what is the coefficient matrix here? The coefficient matrix is 1 minus 3 1. You can check from here. Minus 1 4, minus 4, 2 minus 1 5. And what is B? 4a, a minus 3a. Okay. Okay. I think here we have plus 3. Sorry. Okay. So first of all, I have to check whether this system can be solved or not. So I will check whether the determinant of this system, this matrix, is 0 or not 0. So how to find the determinant of this matrix? I told you previously. First of all, you will write this value, then something, then minus, then this value, and then something, then plus the last value, and then something. What is this something? You check, I have written 1 here. So if I write 1, that means I will kill this column and this row, and I will write the determinant of this matrix here. What is the determinant? 4 times 5 minus 1 times minus 4. Okay, now I have here minus 3. So I will kill this and this. I will write the determinant of the rest one. What is that? Minus 1 times 5 minus 2 times minus 4. The last thing is 1 and 1 is this. So I kill this and this. Determinant of this is what? Minus 1 times minus 1 minus 2 times 4. Let's compute this. 4 times 5 minus 4 minus 3 times minus 5 plus 6 plus 1, 1 times 1 minus 8. 4 times 5 is 20, 20 minus 4 is 16, this is 16. Minus 3 times, what is this? This is 1. Sorry, this is not 6. This is minus 3, you can check. This is minus 3. This is minus 5, and this is plus 8. 4 2 times 8. So this is 3 times 3. So plus 1 times minus 7. So 16 minus 9 minus 7, which is 0. Since the determinant of A is 0, so the matrix is non-singular. That means the system is not Cramer system. Since the system is not Cramer system, we cannot go to the step 2. Since the determinant is 0, so that means inverse does not exist. So if inverse does not exist, we cannot find the inverse. Okay. Look at the next example. In this example, we have a transportation model, and the transportation model is supported by this matrix P, and the current distribution is denoted by x now, and this is equal to this. And we have to find the previous year's distribution for x previous years if this condition satisfied. And this example is very simple. If you want to find previous year's distribution, you have to take this matrix to this side. How can you do this? When you will take this P here, it will be P inverse. How? P inverse x now. And how to find P inverse? This is P. You can find P inverse using row reduced HLN form. When you will get P inverse, then you will put the value here and multiply this with x now. You will get the previous year's distribution. So in this example, your main task is to find the inverse of this matrix, and I have already taught you how to find the inverse of this matrix. Okay, now there are some exercises. The next one is exercise I am leaving for you. In the next page, in slide number 15, we have a theorem. Let's do a theorem. If A is invertible, so if A is invertible, then the inverse of A inverse is A. Okay, so how to prove this? Since this, suppose that this is matrix X, So what does that mean? X inverse is A. So how to prove that the inverse of x is A? I told you the definition. If you multiply x with A, and if you end up with identity, also if you multiply A with x, you end up with identity, then we will say that x is the inverse of A. No, A is the inverse of x. Okay, both are inverses of each other. So what I have to do, I have to do multiplication of this matrix with the matrix inside the inverse. This is the main inverse. So I have to do multiplication of this A with inside the inverse of the matrix, and I will expect to have identity. So what I do, if I multiply this with the matrix inside this inverse, I mean A inverse, and if I will get identity, then that means this thing is true. And you now, if I multiply these two, I will end up with identity, because A and A inverses are inverses of each other, hence proved. Okay. Also we have to do this multiplication in the reverse side as well. For example, I have done A here, A inverse here. Now I have to do A inverse here and A here. Still I am getting identity. So from both sides I am getting identity. That means this equation is true. Okay. So okay, let's break this video.